The use of geometry and attention to the aesthetics of geometric designs have been of interest to humans since ancient times. For example, in this pottery vessel from prehistoric civilizations of central Iran, the use of circular arcs, a four-petaled flower with a geometric design, and this network of diamonds can be observed. And in this stoneware from ancient Girov civilization, southern Iran, 3rd millennium BC, the entire design is curated by combining various geometric motifs: circular arcs, squares, equilateral triangles, rectangles, and others. We can observe the use of geometry in art across the works of all civilizations: China, India, ancient Rome, and almost any other civilization. However, it's no exaggeration to say that the most intricate use of geometry in art and architecture can be observed in Islamic civilization. The foundations of this art can be seen in the architecture and artistic works of the Persian and Roman empires. Their legacy was passed on to Islamic civilization, where it underwent a profound transformation. Two examples of pre-Islamic architecture in Iran: Zaha Castle, 3rd century, and Ardeshir Palace, again from 3rd century, Firuzabad, Iran. Another example of geometric art in pre-Islamic Iran from Sassanid period. Geometric designs are used in various forms of art: tiling works, carpets, wooden windows, engraving on copper, and many other forms of art. Even in this miniature painting from 14th century, we can see many geometric designs. Arches and domes also have beautiful geometric designs based on combination of circular arcs. Beautiful examples of domes from Jame Mosque of Save, 11th century, Charbagh Madrasa, 17th century. It's evident that designers of these patterns possessed sufficient knowledge of Euclidean geometry and its drawing methods, which uses only a ruler and a compass. An important historical book which shows what kind of geometric knowledge was used by architects is a book entitled On Those Geometric Constructions Which Are Necessary for Crafts Workers, written by Abul Wafa Buzjani, an 11th century Persian mathematician. It contains methods for elementary geometric drawings, like drawing a perpendicular line to a given line, dividing a line segment to a few equal parts. For example, here the line segment AB is divided to 3 equal parts, drawing the bisector of an angle, drawing a regular polygon on a given line segment. For example, here on the line segment AB, a regular pentagon is constructed, drawing a regular polygon inside a circle. Even more advanced topics such as methods for angle trisection and cube duplication using a movable ruler. We know that these classic problems are not exactly solvable using a ruler and compass, but if we allow the ruler to move freely, movable ruler, it's possible to solve these problems. Drawing a parabola with arbitrary precision, and even covering the surface of a sphere with regular polygons. This knowledge is far more than what we need in this course, and basic geometric construction along with methods for drawing regular polygons are sufficient for us. If you don't want to draw the patterns on paper, another method is using a software like GeoGebra. In fact, all construction in this course have been done using this software. GeoGebra is very easy to use and you can easily find the necessary tools for all geometric constructions. Drawing a point, a line segment, a line passing through 2 points, a ray, drawing perpendicular to a given line at a given point, drawing perpendicular bisector of a given line segment, drawing a regular polygon on a given line segment using this tool. I need a regular pentagon. I enter 5 and we have a regular pentagon. Drawing an angle, I can complete it by drawing 2 rays. Drawing an angle with an arbitrary size using this tool. Here I draw an angle with the size of 70 degrees. We can draw clockwise or counterclockwise. Using this tool, we can divide a circle into any number of equal arcs. For example, if I want to divide this circle into 10 equal arcs, it's enough to draw an angle with the size 36 degrees, and by repetition our circle will be divided into 10 equal arcs. Drawing an angle bisector, finding midpoint of a line segment using this tool. Drawing a circular arc using this tool. It's also very useful in our constructions. Reflection about a line. Reflection about a point. Here I use the reflection about the point, the circle. And parallel to a line from a given point. Have this line and the point. We draw a line parallel to that from this point. And a tangent to a given circle from a given point. For example, we have this point here. We can find the 2 tangent lines from this point to this circle. Rotating around a point, for example, we have a circle here and we rotate it around this point using this tool here, rotate around point. by, for example, 90 degrees. And finally, if you want to remove an object, you select this one, move, right click on that object and uncheck the show object option here, and it's removed. It's all we need from GeoGebra. Almost no book explaining step-by-step drawings of these patterns has reached us from past centuries. Perhaps the only exception is the following book, which explains methods for drawing a few patterns. Its title is On Similar and Complementary Interlocking Figures by 11th century Iranian mathematician Abu Ishaq Kubanani. Scrolls are another important historical source. For example, the famous Topkapi scroll, now held in Topkapi Museum, Istanbul, which contains some completed patterns and sometimes subgrids used for drawing the main pattern. Some pages from Topkapi scroll. It's a part of Mirza Ali Akbar scroll, 19th century Iran, now kept in Victoria and Albert Museum, London.